Imagine a world without calculators or computers. How would we perform complex calculations? This was the reality before John Napier, a Scottish mathematician, revolutionized mathematics with his invention of logarithms. His groundbreaking work simplified complex calculations, transforming fields like astronomy, navigation, and engineering. Napier's invention was not merely a mathematical curiosity, it was a practical tool that addressed a pressing need of his time: the demand for faster and more accurate calculations. His work serves as a testament to the power of human ingenuity to overcome challenges and shape the course of history. John Napier was born in 1550 in Merchiston Tower, near Edinburgh, Scotland. His family was wealthy and influential, providing him with access to a good education. However, details about his early schooling remain scarce. It is believed that he may have attended St Andrews University for a brief period. Despite the lack of formal mathematical training, Napier possessed a natural talent for numbers and a keen interest in solving problems. He dedicated himself to studying mathematics, theology, and natural philosophy, pursuing knowledge with a passion that would define his life's work. Napier's intellectual curiosity was fueled by the Renaissance, a period marked by the rediscovery of ancient knowledge and a renewed interest in scientific inquiry. His work reflects this spirit of exploration and innovation, pushing the boundaries of human understanding. During Napier's time, astronomy and navigation were rapidly advancing. These fields relied on complex calculations involving large numbers, often requiring hours of tedious work. Astronomers needed to calculate planetary positions, while navigators used celestial observations to determine their location at sea. These calculations involved multiplication, division, and the extraction of roots, all of which were incredibly time-consuming and prone to error when done manually. The need for a faster, more efficient method was clear. Napier recognized this challenge and dedicated himself to finding a solution. His invention of logarithms would prove to be the answer. Napier's breakthrough came with his discovery of logarithms, a mathematical tool that simplifies multiplication and division into addition and subtraction. He achieved this by expressing numbers as powers of a base. This seemingly simple concept revolutionized calculations, making complex problems significantly easier to solve. For example, the logarithmic relationship log AB equals log A plus log B demonstrates how multiplication can be simplified into addition using logarithms. This property applies to other operations as well. Division becomes subtraction, exponentiation becomes multiplication, and root extraction becomes division. Napier published his work on logarithms in 1614, introducing the world to this powerful tool. His tables of logarithms provided mathematicians and scientists with a reference for performing calculations more efficiently, greatly reducing the time and effort required for complex computations. Section 5. A collaboration for practicality. Napier's work on logarithms was further refined through his collaboration with Henry Briggs, an English mathematician. Briggs recognized the practical advantages of using a base 10 system for logarithms, which aligned with the decimal system commonly used for calculations. Together, Napier and Briggs developed tables of base 10 logarithms, also known as common logarithms. These tables became indispensable tools for scientists, engineers, and anyone performing complex calculations. The collaboration between these two mathematical minds exemplifies the power of shared knowledge and collaboration in advancing scientific understanding. The impact of their work was profound and far-reaching. Logarithms became essential tools in fields like astronomy, physics, and engineering, enabling scientists and engineers to tackle increasingly complex problems with greater accuracy and efficiency. Section 6. Napier's bones, a mechanical marvel. Napier's ingenuity extended beyond theoretical mathematics. He was not just a thinker, but also a practical inventor. He also invented a calculating device known as Napier's bones, a tool that would revolutionize the way calculations were performed in the early 17th century. This device, introduced in 1617, used a series of rods inscribed with numbers to perform multiplication and division mechanically. Each rod was meticulously crafted to represent a digit. By arranging the rods in a specific order and following a simple set of rules, Users could perform calculations without needing to memorize multiplication tables or perform manual arithmetic. This was a groundbreaking development for its time. Napier's bones were a significant step towards the development of mechanical calculators. They laid the groundwork for future innovations in computational devices. While relatively simple compared to modern calculators, Napier's bones were widely used in his time. They were especially valuable for merchants, surveyors, and anyone involved in trade or navigation. They provided a faster and more reliable alternative to manual calculations, especially for those who were not mathematically inclined. This ease of use made them popular across various fields. This invention highlights Napier's practical approach to problem solving and his desire to make mathematics more accessible. His work with Napier's bones is a testament to his innovative spirit and his lasting impact on the world of mathematics. Napier's bones not only simplified complex calculations but also inspired future generations of mathematicians and inventors to think creatively about problem-solving tools. Section 7. The decimal point, a small dot with a big impact. The decimal point, a seemingly insignificant dot, has revolutionized the way we perform calculations and understand numbers. John Napier, a Scottish mathematician, also played a crucial role in promoting the use of the decimal point in mathematical notation. His work laid the foundation for more complex mathematical concepts. Though the concept of decimals predates Napier's, he recognized their importance in simplifying calculations. Before decimals, fractions were the primary way to represent parts of a whole, which often made calculations cumbersome and error-prone. Napier advocated for their standardized use, influencing mathematicians like Simon Stevin, who further popularized decimals in Europe. Stevens' work, De Tiende, was instrumental in spreading the use of decimals across the continent. The decimal point provided a clear and concise way to represent fractions, making calculations involving decimals significantly easier. This innovation allowed for more precise measurements and calculations, which were essential for advancements in science and engineering. This seemingly small notational change had a significant impact on the development of mathematics, paving the way for the modern Hindu-Arabic numeral system we use today. The decimal system's simplicity and efficiency made it the preferred choice for mathematicians and scientists alike. Napier's contribution to the widespread adoption of the decimal point underscores his understanding of the practical aspects of mathematics. His work demonstrated that clear and efficient notation is essential for progress in any field involving numerical calculations. The decimal point, though small, has had a big impact on the world of mathematics. It has enabled more accurate and efficient calculations, which in turn have driven progress in various scientific and engineering disciplines. The legacy of Napier and other pioneers in this field continues to influence the way we work with numbers today. Section 8. Beyond mathematics, Napier's diverse interests. Napier's intellectual curiosity extended beyond the realm of mathematics. He was also deeply interested in theology and astronomy, reflecting the multifaceted nature of Renaissance thinking, where disciplines often intertwined. Napier wrote extensively on biblical prophecy, particularly focusing on the Book of Revelation. His theological writings, though less influential than his mathematical work, provide insights into his religious beliefs and the intellectual climate of his time. In addition to his theological pursuits, Napier applied his mathematical skills to practical problems in ballistics and surveying. He was particularly interested in military engineering, writing treatises on fortifications and siege warfare. His work reflects a desire to apply his knowledge to real-world problems, demonstrating the practical applications of mathematics in diverse fields. Section 9. Napier's enduring legacy, a mathematical pioneer. John Napier's legacy as a mathematical pioneer is undeniable. Born in 1550, Napier was a Scottish mathematician whose innovative ideas and inventions have left an indelible mark on the world of mathematics. His invention of logarithms revolutionized calculations, making complex problems solvable and paving the way for advancements in science and engineering. Before logarithms, calculations were laborious and time-consuming, but Napier's work simplified these processes, enabling scientists to focus on discovery and innovation. His contributions extend far beyond the realm of theoretical mathematics, impacting fields as diverse as astronomy, navigation, and computer science. For instance, logarithms were crucial for astronomers charting the stars and navigators plotting their courses across the seas. Napier's work embodies the spirit of the scientific revolution, a period marked by a thirst for knowledge and a drive to understand the world through observation, experimentation, and mathematical reasoning. His methods and ideas were instrumental in the shift from medieval to modern scientific thinking. His legacy continues to inspire mathematicians and scientists today, reminding us of the power of human ingenuity to overcome challenges and shape the future. Modern researchers build upon his foundations, pushing the boundaries of what is possible in mathematics and science. As we rely on increasingly sophisticated calculators and computers, it's easy to forget the groundbreaking work of pioneers like John Napier. His innovations laid the groundwork for the digital age, influencing the development of algorithms and computational methods. His contributions remind us that even the most complex technologies have their roots in fundamental mathematical principles that continue to shape our understanding of the universe and our place within it. From the simplest abacus to the most advanced quantum computer, Napier's influence is a testament to the enduring power of mathematical thought.